All right, so we're going to call this Intro to Limits. And we are in a whole new module. Can you turn off the right set of lights? I might brighten that up a little bit. Yeah, thank you. Well, okay, turn off the left set and leave the right set on. Better? A little better? All right, so limits. When we are finding the limit of a function, we are finding the point on a graph where x is approaching a number what number is y approaching. And that's kind of like my own, in my own words kind of definition, so it's not too technical. Hopefully I said it right. So a lot of you will be going on to take calculus, right? This finding limits in calculus is, I think, one of the first things that y'all do. And it's very important to know how to find limits algebraically and graphically if you're going on to calculus, all right? And it's fairly, a lot of the problems are fairly simple. When you get into problems that have radicals or complex fractions, it gets a little bit more complicated. But the more practice that you have with limits, the easier that it is, okay? So we're going to do lots of examples. We will not have an assignment today. That does not mean you don't pay attention. All right, so the first one, we're going to find the limit. Usually you see it like in cursive, LIM, and then you'll see as x approaches 2. That's what that means. So on the graph, before I started the video, I put in the function x squared minus 4 divided by x minus 2. So if I were to graph this, which I did on Desmos before I started this video, and I said, okay guys, as x is approaching 2, what is y approaching? So if you have Desmos, it's pretty easy to put it in and just see what your y value is when your x value is 2, right? As your graph is getting closer and closer to 2, what is it getting closer and closer to on the y-axis? That's what you're finding. But we have to find it mathematically, all right? So one thing that you can try is just use direct substitution. Whatever that value as x is approaching 2, let's just plug that in and see what we get, okay? And make yourself good notes on these. Use direct substitution to start. Meaning, substitute x equals 2 into the given function and simplify. So if that was as x is approaching 4, plug in a 4. As x is approaching 5, plug in a 5. It's not always 2. It's whatever your x is approaching, okay? So I'm gonna, and I don't want to write it next to it, right next to it, because I want to see when I'm looking back on my notes, I want to be able to tell what the original problem was and then how I changed it. All right, so I'm going to say 2 squared minus 4 divided by 2 minus 2. So 2 squared is 4 minus 4 over 2 minus 2 is 0. Well, 4 minus 4 is 0 over 0. Isn't that undefined? Okay, then this method's not going to work on this example. Okay? When you have a fraction and there is a variable in the denominator, if the number that we substitute in, if it's going to give us a 0 in the denominator, then we can't use that method. Just like in this example, because what we got is undefined. And we saw on the graph that it was approaching some number on the y-axis, correct? There was a number there. So let's make a little note of that. When there is a variable in the denominator, we can't always start with direct substitution. If by doing so, we will get a 0 in the denominator, we will need to choose a different method. All right. So let's go back and look at our function. X squared minus 4 divided by the quantity of x minus 2. We know we can do it graphically, but we're pretending we don't have access to a graph or a graphing device. So let's try factoring, okay? Could we factor either the numerator or the denominator or both? Well, x squared minus 4, isn't that a difference of 2 squares? Perfect square minus a perfect square? It's a special case, right? We can factor that. Also, you can think of it as it's a quadratic, where a is 1, b is 0, c is -4. We could do the t-chart and divide and slide as well. But we can factor. So let's try to factor. When what we want to happen is we want that denominator to go away so that we can plug in a 2. Because if we don't have a denominator, we don't have to worry about the denominator being 0. All right? So the next thing we're going to try is factoring. So let's try to start by factoring. Our goal is to cancel out the denominator so that we can try direct substitution again. And I know y'all hate writing all these words, but if you don't explain it in your notes when you go back and look at it, you're gonna be like, maybe tonight you won't forget, but down the road when you go to study, like, why did we do that? That doesn't make any sense. You write it down in your notes and you read it, and you're like, oh yeah, I remember now. So I'm gonna rewrite my problem. We're gonna find the limit as x approaches 2 of x squared minus 4 quantity divided by x minus 2. So our numerator is a difference of 2 squares. That's a perfect square minus a perfect square. You can factor that super easy without a T-chart and divide and slide. You got to just remember what its identity is. Perfect square minus a perfect square make 2 sets of parentheses. One gets a plus in the middle, one gets a minus in the middle. The first term in each set is the square root of the first term. What's the square root of x squared? X. The second term in each set is the square root of the absolute value of the second term. What's square root of 4? 2. So if we multiplied that all out, we would get x squared minus 2x plus 2x minus 4. The two middle terms would cancel. That'd give me x squared minus 4, correct? So that's factored. Can I factor the denominator? No, it's linear, and the only way to factor a linear expression is if it has a GCF. Well, and anyway, I can clearly see that it's identical to one of the factors of the numerator. Sweet, that's what we were hoping would happen. So they will cancel each other out. So now we can find the limit as x approaches 2 when we have x plus 2. So now that if we substitute in a 2, we won't get a 0 in the denominator. Now we can use direct substitution. Okay, so now I'm going to substitute for x. I'm going to substitute in a 2 for x, then add the 2, and we get 4. So you could say the limit as x approaches 2 is equal to 4. As we get closer and closer to 2 on the x-axis, the graph is getting closer and closer to 4. So let me pop that graph back up again. So on the x-axis, as we're getting closer and closer to 2, right? So on the graph, as the graph's getting closer and closer to 2 on the x-axis, the y is getting closer and closer to the 4 as we approach it from the left, or if we were coming from the right, as we get closer and closer to 2 on the x-axis, on the y-axis, we're getting closer and closer to 4. Does that make sense? Okay, yay. All right, example 2. So if at home, you're like, well, I'm just going to pull up Desmos, put this in, and look at the graph. Well, am I going to give you credit for that if you don't work it out algebraically? No. So it's a good way to check it, but I'm going to give you, for you to get credit on this assignment, which we won't have an assignment today, you're going to have to show me algebraically how you got the answer. All right, so example 2. What is the limit as x approaches 5 of x squared plus 2x minus 4. And sometimes I like to write how you say things, like when you're describing it back to me. So we would say, what is the limit as x approaches 5 of x squared plus 2x minus 4. So on this one, do we need to worry about getting a 0 in the denominator? No, because there is no, well, the denominator is 1. There's no variable in the denominator, right? So again, I know y'all hate writing the words, but I don't want you to be like, why didn't we just, I don't understand, okay? There's no fraction. So we don't have to worry about getting 0 in the denominator, which I'm going to say, I'm going to abbreviate denom. So we can start with direct substitution. Coolio. That's nice when that happens. When you can just go ahead and substitute in the number and take off, then awesome. So we'll do 5 squared plus 2 times 5 minus 4 equals 25 plus 10 minus 4. 25 plus 10 is 35. 35 minus 4 is 31. So as x is approaching 5, y should be approaching 31 if we were to graph this. Well, that's easy. Good with that? Example 3. The problem with limits is there's so many different kinds of problems you can have. Fortunately, we've learned how to factor quadratics, sum of cubes, differences of cubes. We've learned what to do with complex fractions, with radicals. We know how to do all of these things. It's just now we're kind of putting it all together when we do limits. So it's a lot to remember. So example 3, we have x cubed minus 27 quantity divided by x minus 3. Oh, I forgot to write what the limit is. Sorry. As the limit is approaching 3. What is the limit as x is approaching 3? So if I go ahead and use direct substitution, is that going to work? No, because we're going to get 0 in the denominator, right? We can't do that. Okay, we'll try factoring. X minus 3 doesn't factor. X cubed minus 27, that's a special case, just like the last one was a difference of squares. Is this a difference of squares? No, what is it? Difference of cubes. We factored difference of cubes this year, didn't we? Little review. When you have a difference of cubes, say you have a cubed minus b cubed. To factor that, you do the cube root of the first term minus the cube root of the second term, a minus b. And then in the second parentheses, you're going to have 3 terms. Then do that first term squared plus these 2 terms multiplied together the absolute value of them. So plus AB plus this second term squared, plus B squared. If you don't remember how to factor sum and difference of cubes, you might want to go find some videos to refresh yourself or look back in your notes. All righty? So in this example, let's do x cubed minus 27. And I know a lot of y'all can do this in your head, but you know me. So my A would be the cubed root of the first term. So what's the cubed root of x cubed? X. My B is the cubed root of the absolute value of the second term. So what's the cubed root of 27? Is 7 times 7 times 7 27? 3. 3 times 3 times 3 is 27, correct? So to factor that, in the first group, we do A minus B, which is going to be what? X minus 3. I made myself not have a lot of room. And then A squared, which in this case, that would be X squared. And then it says we add AB. So in this case, that's going to be 3X. And then we add the second term squared, so 9, right? All over the denominator, x minus 3 is not factorable, and we don't care anyway because we can see it's clearly going to cancel with the x minus 3 in the numerator. That's what we want to happen. That way, we can use direct substitution. So now let's find what is the limit as x approaches 3 when we have x squared plus 3x plus 9. So now that that denominator's away, okay, these two functions that I have written, they are equivalent to each other. It's just they had a common factor that I canceled. So these two are equivalent, okay? They mean the same thing. But now that I don't have that denominator, now I can use direct substitution. So we have 3 squared plus 3 times 3 plus 9. So that gives us 9 plus 9 plus 9, which is 27. So we could say the limit as x approaches 3 of this function is equal to 27. Cool, yeah? Any questions so far? Before we get into a complex fraction. Good thing we already know how to simplify complex fractions, am I right? Yeah. Let's see, I think I can fit another one here. Example 4. We are going to find what is the limit as x approaches 3 of 1 over x minus 1 over 3 quantity divided by x minus 3. Okay, we want to get rid of that denominator because if we use direct substitution, we're going to get a 0 on the denominator, right? Okay, but can we factor the numerator? I don't think so. So let's just start by trying to get rid of that complex fraction. We don't want a fraction within a fraction. So do y'all remember what to do? Multiply everything by the LCD. So to get rid of a complex fraction, multiply each term by the LCD. So what is the LCD? Right, but in this case, what is that? 3x. Now remember, this x minus 3 in the denominator, it has a denominator of 1, okay? This fraction has a denominator of x. This fraction has a denominator of 3. So the least common denominator would be 3x. Hold on, I know somebody asked a question. Oops. Oh, close, Michaela. 3x. 3x is your LCD. Because if we just use 3, well, this x wouldn't cancel out, right? If we just use x, then the 3 wouldn't cancel out. So your LCD is 3x. Make sure you multiply every term. Now the denominator, that binomial, the whole thing is being multiplied by 3x. So you got to distribute. So in the numerator, 3x times 1x, well, the x's cancel. And let me just cancel everything that I can. Minus 1/3 times 3x, the 3's cancel. And the denominator, nothing cancels. So we're going to go back, see what we have left. So now we have, only thing we have is 3 times 1 is 3, minus 1 times x is x. And in the denominator, we're wanting factors to cancel, right? So if we multiply 3x and x minus 3, it's already factored. So don't do that because we're hoping that it factors with something. So just leave it as 3x times x minus 3. Again, we still can't plug in a 3 right now because we're getting a 0. Now, is 3 minus x equivalent to x minus 3? No, because the x is negative in one and positive in the other. The 3 is positive in one and the negative in the other, right? Well, so it can't cancel as it is currently. Well, what if I factored out a negative 1 from the numerator? If I factor out a negative 1, so 3 divided by negative 1 is negative 3. Negative x divided by negative 1 is positive 1x, or just positive x. Now, is negative 3 plus x the same thing as x minus 3? Yeah, because I could rewrite that, right? Negative 3 plus x is the same thing. I could rewrite it as x minus 3. Do I have to rewrite it to cancel it out? No. If it confuses you, rewrite it. But just let me point out, 3 minus x will not cancel with x minus 3. But if we just factor out a negative 1, that will change both signs, and then they will become exactly the same. Then we can cancel them out. Okay? That's good. That's what we wanted to happen. Equals negative 1 over 3x. Now, we have not used the direct substitution yet, so I still write what is the limit as x approaches 3. Now, would we be able to use direct substitution now? Yeah, but you're like, but wait, there's still a variable in the denominator. Well, if we plug in the 3, if we substitute 3 in for x, is that going to give us a 0? No, as long as we don't get a 0, we can plug it in. That's what we wanted to happen. But while we still had that x minus 3, if you plug in a 3 there, 3 minus 3 is 0, times 3 times 3 is 9, 0 times 9 is 0. But right now, if you plug in a 3, you won't get a 0. So negative 1 divided by 3 times 3 is negative 1 over 9. And that is our answer. The limit as x approaches 3 is equal to negative 1 over 9. All right. Questions so far? And don't worry, we'll do some more notes on tomorrow. I won't just throw you right into, because this is a lot, throwing a lot together. We'll do more practice tomorrow before I give you an assignment. Example 5. What is the limit as x approaches 9 of the square root of x, and then you have a minus 3 that's not under the radical, quantity divided by x minus 9. Can we start with direct substitution? No. Because if we do, we'll get a 0 in the denominator. Can we factor anything? What can we factor? If this was x squared minus 9, it'd be a difference of squares, but it's not. The numerator, that's not factorable. So there's nothing to factor. Can't go that route. It's not a complex fraction, right? So we can't do the same thing we did in the last example. Well, we do have a radical. Now, usually when we multiply by the conjugate, like a fraction that's made out of the conjugate, we usually multiply by the conjugate of the denominator, right? But in this, because we don't want a radical in the denominator. Well, in this case, the radical's in the numerator. So let's try by multiplying by the conjugate of the expression that has the radical. Sometimes it might be in the denominator. This case, it's in the numerator. So multiply by the conjugate of the expression that has the radical. So I'm going to rewrite my problem. Again, I like to know in my notes, what was the original problem? Because sometimes you just write the first step. You don't rewrite the problem. When you go back and look at your notes, you're like, was this the problem? Or did I already start simplifying it? So the numerator is what has the radical in it. So what is the conjugate of the square root of x minus 3? The square root of x plus 3. Very good. So we'll multiply by the square root of x plus 3, and that plus 3 is not under the radical, over the square root of x plus 3. Now, I still can't substitute in the 9 because that's going to give me a 0 here, and a 0 times anything is going to be 0, right? So I still can't do that. There's going to be a lot of distributing, so be careful. All right, what's the square root of x times the square root of x? Just x, correct, because it's the square root of x squared, and the square root of x squared is x, right? The square root of x times positive 3 is positive 3 square root x. That 3 is not under the radical, it's outside. X is under the radical. Now let's move to the negative 3. Negative 3 times the square root of x is negative 3 square root x. And negative 3 times positive 3 is negative 9. Sorry about all the lag time in the video, guys. Y'all know how it is. All over and the denominator. What's x times the square root of x? X, what? X square root x. Oh, wait. I see what I'm yes, okay. I'm like, wait a minute. Why isn't this looking the same as my notes? Okay. Yes, that is true. It is x square root of x. However, You know how we really want something to cancel our denominator out? And if we multiply these together, then we're going to have to refactor it, and we don't want to do that, especially with that radical. So let's don't multiply the denominator together. Let's just leave it in this factored form. I said leave the denominator in factored form because we're hoping something will cancel out the x minus 9. Why don't I care about the square root of x plus 3? Why don't I care if that's factored out? And usually we're trying to get a radical out of the denominator. But why do I want the x minus 9 to cancel and not the square root of x plus 3? Right, because if I do direct substitution, 9 minus 9, 0. The square root of 9 plus 3 is not going to give me 0, right? So I'm totally fine with using direct substitution with this factor, but 9 minus 9 is going to give me 0. So that's why I'm wanting that to cancel. I don't care about the other one, it's fine. So my numerator, positive 3 square root of x and negative 3 square root of x will cancel and just leave me with x minus 9. And the denominator, have x minus 9 times the square root of x plus 3. Will anything cancel? X minus 9, yes, that's what we were hoping for. So, what is the limit as x approaches 9 of, what do I put in the numerator now? A 1, can't just be blank, right? Got to put, or a 0, it's not 0, so 1 over the square root of x plus 3. Now, what do you think we can do? Can we use direct substitution now? Yes, because we won't get a 0 in the denominator if we substitute in a 9 for x. So now we can use direct substitution. So once you put in the direct substitution, you don't keep rewriting what is the limit as x approaches 9. You don't write that again once you put in direct substitution. So we'll just say 1 over the square root of 9 plus 3 equals 1 over, what's the square root of 9? 3 plus 3 equals 1 over 6. The limit as x approaches 9 is equal to 1/6 in this function. I've got one more example. It's 11:09. I can get it done in 10 minutes, I think. So you see how there's so many different types of problems that you could have? And this is just the surface. This is intro to limits. Can I go on to example 6? Okay. What is the limit as x approaches 4 of 1 over the square root of x minus 1/2 quantity divided by x minus 4? Can we start with direct substitution? No, sadly. Okay. So I want that x minus 4 to go away, but also I have a complex fraction that I would like to get rid of. So what could we multiply? What's the least common denominator we can multiply everything by? 2 times the square root of x. And I'm not rewriting this only because I'm using a different color. If you don't have a different color, then I would rewrite it so that you know what your original problem was before you changed it. Again, normally we don't want to put radicals in the denominator, but in this case, we're just trying to get that x minus 4 to go away. So you got to do what you got to do. So top left, the square root of x is going to cancel. Top right, the 2 is going to cancel. And in the denominator, nothing cancels. But remember, we don't want to distribute those. We want to leave them as separate factors. Okay? So what is the limit as x approaches 4 when? Let's see what we have. Top left, 2 times 1 is 2. Minus top right, we have 1 square root of x, which is just square root of x. All over 2 square root of x times x minus 4. Okay, now, remember I think it was the last example. You have to kind of think about it. I do have a radical in the denominator, and I also have a radical in the numerator. But what we're going to do is we're going to multiply by the conjugate of the 2 minus the square root of x in the numerator, okay? If you don't do that, and you do, because in the denominator we got those 2 separate factors, I don't know, it could be confusing. This one is kind of confusing anyway. So just trust me on this one. We're going to multiply by 2 plus the square root of x. It's the conjugate of the numerator. Because what we're trying to do, we're trying to get the numerator to turn into something that has a x minus 4 in it, okay? And you're like, well, this doesn't look like that's going to do it, but let's just give it a whirl. So when we distribute, in my numerator, 2 times 2 is 4, plus 2 square root of x minus 2 square root of x. See how it's going to make those go away. And then minus, what's the square root of x times the square root of x? X. So are you seeing how those 2 middle terms are going to cancel each other out, and then we'll have 4 minus x, which is not x minus 4, but we could factor out a negative 1, right? So that's what we're hoping for. We're trying to get something that makes that x minus 4 in the denominator go away. Again, don't distribute your denominator. Leave it as 2 separate factors. So again, I keep writing what is the limit as x approaches 4. I keep writing that until I actually do direct substitution. So in the numerator, 2 square root of x minus 2 square root of x cancels. I've got 4 minus x. If you want to rewrite that as minus x plus 4, you can, but don't rewrite it as x minus 4 because that's not what it is. X is negative, 4 is positive. And you don't have to rewrite it. In the denominator, leave it as 2 square root of x times x minus 4. Now, is anything going to cancel? Not yet. But if we could just turn this x positive and this 4 negative, it would cancel, right? Can we just do that? Just change it? No, what would we have to do? Factor out a negative 1. Is that okay? Can you do that? Totally. So I don't need to put these equal signs. I don't know why I'm putting that. So I'm going to factor out a negative. If you want to put negative 1 or negative, it doesn't matter. So negative x divided by negative 1 is positive x. Positive 4 divided by negative 1 is negative 4. Go back and redistribute in your head to make sure negative 1 times x is negative x, negative 1 times negative 4 is positive 4. You don't want to accidentally change the meaning. Now what? Oh, we can cancel. Oh, Michaela, you bring up a good point. I made a mistake. Michaela said, where does the 2 plus the square root of x go when you multiplied it in the denominator? Up here, when I did the numerator, right, I've distributed all that out, but in the denominator, I only brought down 2 square root of x and x minus 4. I was wanting to be careful not to multiply anything out, but I forgot to bring down 2 plus the square root of x. Thank you so much. So that is not gone anywhere. That was a mistake on my part. Thank you so much for pointing that out, because we would not have gotten the right answer. Okay, so that didn't mess us up. It would have if you wouldn't have said that. It would have messed us up, but we just need to add it on to our problem. So now in the numerator, I only have -1 because the x minus 4 is canceled out. And the denominator, I have 2 times the square root of x and also 2 plus the square root of x. So I've got the variable of x in 2 separate places. If I use direct substitution, will either of them turn into a 0? No. Yes. Because we got rid of that x minus 4, we can now finally use direct substitution. So I have -1 divided by 2 times the square root of 4 times 2 plus the square root of 4 equals -1 divided by, what's the square root of 4? Times the 2 on the outside is 4 times 2 plus the square root of 4. So that'd be 2 plus what? Which is 4. So what's my final answer? -1/16. So again, they're going to take some practice. This is just our little intro. And we did some of the harder problems, but we'll have more practice. All right, so that's the end of my video. Everybody go to lunch, and all my e-learners, we will see you tomorrow. Uh-oh, hold on, another chat. Yes, Delmar, I will do that.
Bye, Miss Rayleigh. Hope you have a good day.
Bye, thank you, you too.